Hi girls, I'm going to record this lesson for you. So we're going to mark some of the common titration questions or the C4 calculation questions. So question 1 asks, the student carried out titration to find the concentration of a solution of sulfuric acid. 25 centimeter cubed of sulfuric acid solution was neutralized exactly by 34 centimeter cubed of a potassium hydroxide solution of a concentration 2 moles per dm cubed. They give you the equation for the reaction. But first of all, what they want you to do is they want you to describe the experimental procedure carried out by the student. Okay, so girls, for your answer, you needed for the following points. Remember, sulfuric acid was measured by the pipette. The potassium hydroxide is in burette, or you could have drawn a diagram for this. However, the diagrams need to be labelled. Okay. So because you have a regular amount, 25 centimeter cubed, this indicated that it used a pipette, because remember, a pipette measures a fixed quantity, whereas burette measures variable. Now, if solutions were reversed, that's fine. You still get your reward if you said one was measured by the pipette, the other was the burette. Note the initial reading. Use indicator to note when the colour change occurs, and note the final reading. So see if you have any 4 of these main points. If you're unsure, ask the person beside you to read your answer. The next point was the number of moles of potassium hydroxide used. So remember, the number of moles is equal to your concentration times volume. We are told that we have 34 centimeter cubed potassium hydroxide, and we're told the concentration. But first of all, we need to convert centimeter cubed to dm cubed, and we do this by dividing by 1,000. So here we have our dm cubed, and we're going to multiply it by our concentration, which will give us an answer of 0.068 moles. Now from this, we're asked to calculate the concentration of sulfuric acid. Okay, so we need to look at our balanced equation for this, girls. So here, you can see your balanced equation, and it tells us for every 2 moles of potassium hydroxide, we have 1 mole of sulfuric acid. So that means 0.068 needs to be divided by 2, okay, to find the number of moles of sulfuric acid. And this is going to give us a value of 0.034, okay? That means we've 0.034 moles of sulfuric acid. We know the moles and we know the volume. The volume is 25 centimeter cubed, but remember it must be in dm cubed. So it'll be 25 divided by 1,000, which gives us 0.025 dm cubed. And if we rearrange our equation, concentration is equal to moles over volume, which is equal to 0.034 over 0.025 dm cubed. And this will give us an answer of 1.36 moles per dm cubed. Okay, if you may need to pause the video throughout and annotate your answers, or check where you went wrong, or even retry it without just copying down. There's no point just copying down what I write. You must try it for yourselves, girls. Okay, next thing, when this ammonium sulfate is an artificial fertilizer, when this fertilizer is warmed with sodium hydroxide, ammonia gas is given off. Describe and give this result for a test of ammonia gas. Now, you're not going to know this. We haven't covered this. So if you did Google it, well done you. If you didn't, that's okay. Okay, so we test it using litmus paper. And it goes blue in the presence of ammonia. Okay. The next one is, we're going to skip this because you're not going to be doing it until year 11. And Ammonium sulfate is made by reacting sulfuric acid with ammonia solution. What is the meaning of strong in terms of ionization? So girls, this question you have not done either, so will not be on your test, but a strong acid is one that fully ionizes or is completely ionized in solution, or where the hydrogen ions are fully dissociated. Okay, so acids are a source of hydrogen ions. The more hydrogen ions present, the more acidic a solution is. A strong acid is when the hydrogen ions are fully able to dissociate. Okay, now, you need a suitable indicator for a strong acid, weak alkali titrations, and this is methyl orange. Now, the next one is a student found that 25 centimetre of ammonia solution reacted completely with 32 centimetre cubes of sulfuric acid at concentration 0.05 moles per decimetre cubed. And we have the equation. So you need to calculate the concentration of ammonia in moles per decimetre cubed. Okay, so first of all, we know the volume of sulfuric acid and we know the mole of the concentration. So we know that moles is concentration times volume. So what we're going to do is we're going to find the number of moles of sulfuric acid. And this is going to be 32 over 100, or sorry, over 1,000, because we want to get it to dm cubed, multiplied by the concentration, which is 0.050 moles per dm cubed. And this is going to give us a value of 0.0016 moles. Okay, now the next thing is it's going to react with how many moles of sulfuric acid. So as you can see here, the number of moles stay the same. Okay, it's because remember the balanced equation tells us the ratio of moles. And it's a 2:2 ratio. Therefore, we have, so those three little dots mean therefore, we have 0.0016 moles of NH3. And we're going to divide this by the volume to find the concentration. And this is going to give us a value. Let's get my calculator. Of 0.064 moles per dm cubed. Okay, now the next one is use your answer to calculate the concentration of ammonia in grams per cubic decimeter. Okay, so if you did not answer PowerPoint B, you don't need to look at that. So you have the relative formula mass. You want to find the grams. If you know the number of moles is equal to mass over mR. And we want to find the in grams per cubic decimeter. So we need to find the mass. So if we know the moles as 0.0016, we multiply it by the mR. This is going to give us 0.0272 grams. Now this was in 25 centimetre cubed of ammonia solution. So we're going to bring this over 0.025. And this is going to give us an answer of 1.09 grams per dm cubed. So what you did was you used the figure, you used your moles value that you calculated here. You multiplied it by the MR to find the mass. Then, once you'd found the mass, you were asked in grams per dm cubed, which told you need to divide the mass by volume. So you divided the mass, 0.0272, divided by the volume, which was given to you at the beginning of the equation when you're told that the student found the 25 centimetre cubes of ammonia solution. Now, the next question, girls. You were asked that household ammonia is a dilute solution of ammonia and water, commonly used to remove grease from ovens and windows. The amount of ammonia in household ammonia can be found by titration. 25 centimetre cubes of household ammonia was placed in conical flask. Describe how the volume of dilute nitric acid required to neutralise this acid of household ammonia can be found accurately by titration. Name any apparatus and materials used. Okay, so what did you need to include? You need to include that you had nitric acid in the burette, okay? And you add nitric acid until there's an indicator change or color change. You note the volume used of your nitric acid, and to achieve an accurate result, you must repeat, okay? So you must include some way of keeping it accurate, or you could use accepted white tile or dropwise near end, or white background, or swirling the flask, or reading meniscus at eye level, but always include repeat, girls, okay? So remember, when you did the experiment, you repeated. Okay, so in an experiment, it was found that 25 centimetre cubes of household ammonia was neutralised by 20 centimetre cubed of a concentration of 0.25 moles per cubic decimeter. So we're given our concentration and we're given our volume. Okay, and we're given our equation. So remember, you're always given the concentration and volume on one of the reactants. And from this, you can find the number of moles using your formula. Moles is equal to the concentration times volume. So what you're going to do is you're going to convert your centimetre cube to decimetre cube by dividing by 1,000. And you're multiplying it by the concentration, which is 0.25 moles per dm cubed. And this is going to give you the number of moles and this is going to give you a value of 0.005 moles Now we look at our balanced equation for our ratio, and we see it's a 1:1 ratio. Therefore, we also have 0.005 moles of NH3. Okay, now what we're going to do is we want to find the concentration. We're going to divide it by the volume used, which was 25 centimetre cubed. And when we divide 25 by 1,000, it's going to give us 0.025. 0.025 dm cubed, and that's going to give us an answer of 0.2 moles per decimeter cubed. Okay, so the next one is the salts. You don't need to do that one. Okay, now the next question is just looking again at how a student could use the apparatus and the solutions in the diagram below to carry out titration. So let's have some look at some of the points that are made in this. Okay, so using your burette, you place the acid in the burette, you place your sodium hydroxide in the conical flask using a pipette. Okay, so you've measured the volume of the alkali placed in the conical flask using the pipette. You must include conical flask, pipette, burette, girls. Okay, now place a few drops of indicator in flask, place the white tile onto the flask, add slowly while swirling and mixing. Note colour change and measure the volume of acid used by noting the volume reading on the burette, reading from the level of the meniscus, and always include to repeat your experiment, girls, because that shows you understand what an accurate result is. Okay. Now, next one was in 1916, during the First World War, a German U-boat sank a Swedish ship which was carrying a cargo of champagne. The wreck was discovered in 1997 and the champagne was brought to surface and analysed. 25 centimetre cubes of the champagne was placed in a conical flask. Describe how the volume of sodium hydroxide solution needed to react completely with the weak acids in 25 centimetre cubes of this champagne can be found by titration using phenolphthalein indicator. Name any apparatus. So it's the same kind of questions over and over again, asking you about the process of a. So please look at some of the answers used. So placing the NaOH in the burette, we added NaOH until the indicator changed colours. Note the volume used or the final reading. One other point, repeat or accept the white tile or adding dropwise, white background, swirling. So very similar to a question we did earlier. Now the acid in the champagne reacted completely with 13.5 centimetre cubes sodium hydroxide with a concentration of 0.10 moles per decimetre cubed. Calculate the concentration in moles per decimetre cubed of acid in the champagne, assuming 1 mole of sodium hydroxide reacts completely with 1 mole of acid. So what we're going to do is we're going to use our moles is equal to concentration times volume. And what we're going to do is we first need to multiply our volume. Divide our volume by 1,000 to get it to decimetre cubed. This is going to 1, 2, 3 bunny jumps, 0.0135 decimetre cubed, multiplied by our concentration, and that's going to give us a value of 0.00135 moles. Therefore, since we were told it was a 1:1 ratio, therefore that is also our moles of champagne. So if we divide those number of moles by the volume of champagne, which was 0.025 decimetre cubed, so we just divided 25 centimetre cubed divided by 1,000. And this will give us a value of 0.054 moles per dm cubed. The next question is analysis by titration enough to decide whether the champagne is safe to drink? So depends. So there's insufficient data, we could say. So that means other substances or bacteria could be present. Okay, the next one, the graph shows how the pH of solution changes during this titration. Phenolphthalein is the indicator used in this titration. It changes colour between pH 8.2 and pH 10. Methyl orange is another indicator. It changes colour between pH 3.2 and pH 4.4. Suggest why methyl orange is not a suitable indicator for this titration. Because, well, it would have changed colour well before the endpoint titration. Before the neutral pH 7, because there's a weak acid present. So remember, methyl orange is an indicator that's used for a strong acid weak base titration. So question 6 is about oven cleaner. An oven cleaner solution contains sodium hydroxide. A 25 centimetre cube sample of the oven cleaner solution was placed in a flask. The sample was titrated with hydrochloric acid containing 73 grams per dm cubed of hydrochloric acid. Describe how this titration was carried out. So again, all you need to include is your HCl in burette. Add indicator to conical flask. Add acid until colour change, and note the volume of acid used. Now, you're asked to calculate the concentration of hydrochloric acid in moles per dm cubed. Okay, so what do you need here? So you have 1 mole. We already know that 1 mole of HCl is when we add up the MRs. So that will give us 36.5 grams per mole. Okay, so that's what we looked at the very beginning. 1 mole of HCl is its grams in molecular mass. Okay, so if we have 73 grams of hydrogen chloride, all we need to do is divide 73 divided by 36.5 grams per mole. This will give us our value for moles per dm cubed, and that's going to give us a value of 2 moles per dm cubed. Okay. Now, 10 centimetre cubes of hydrochloric acid was used to neutralise the 25 centimetre cubes of oven solution. Calculate the number of moles of hydrochloric acid reacting. So first of all, if we have 10 centimetre cubed, if we have 2 moles per dm cubed is the concentration multiply it by the volume to give us the number of moles. The volume was 10 centimetres, so that's 10 over 1,000 because it needs to be in dm cubed. And this is going to give us an answer of 0.02 moles. Now the next thing is calculate the concentration of sodium hydroxide in the oven cleaner in moles per dm cubed. So we are told that the concentration of sodium hydroxide in the oven cleaner in moles per dm cubed. So if we have 0.0, and this will give us our value. Sorry, I'm not too sure what recorded. So we said that this was a fixed volume, therefore it's going to be measured by pipette. Naming a suitable indicator, methyl orange or phenolphthalein. Calculate the number of moles of potassium hydroxide used. So we were told that it had a concentration of 0.4 moles per dm cubed, as well as it had a volume of 25 centimetre cubed, divided by 1,000 to get in dm cubed, and this is going to give us an answer of 0.01 moles. Now, looking at this equation, it's a 1:1 ratio. That means for every 1 mole of KOH, we have 1 mole of HCl. Therefore, there's 0.01 moles of HCl in 35 cm cubed. So what we need to do is we're told it uses 35 centimetre cubed, and to get the concentration is going to be the number of moles over the volume. So it's 0.01 divided by 35 over 1,000. And this gives us an answer of 0.29 moles per dm cubed. So you're constantly just rearranging the equation. Moles is equal to concentration times volume. The next question then is about the extraction of metals. So it says tungsten is a metal, the symbol is W, it's produced from tungsten oxide by reaction with hydrogen. It gives you the reaction of the equation. Calculate the percentage of atom economy when tungsten is produced in this reaction. So again, what you need to do is find the relative formula masses of your reactants, because remember, it's the MR of desired product over the total MR of reactants multiplied by 100. So when we find the MR of the, it tells you that, so it'll be 184 over 232 plus 6 multiplied by 100, and this is going to give you an answer of 77%. Now the next question is very simple. 38% of a rock sample is aluminium oxide. Calculate the mass of aluminium oxide in 40 kg. So what you must do is 38 over 100 multiplied by 40. This gives us a value of 15 kg. So we divided it by 100 to bring it to decimal points. That means for every 1 kg 380 grams are aluminium oxide. Okay, just multiplied it by 40 kg. And then, okay, the next thing is the formula of aluminium oxide is Al2O3. Calculate the relative formula mass. So all you need to do is, well, you have two aluminiums, 3 oxygens, so 16 times 3 plus 27 times 2 is going to give you an answer of 102. Now, 60 kg of aluminium oxide produces a maximum of 31.8 kilograms of aluminium. In an extraction process, only 28.4 kilograms of aluminium is produced from 60 kg of aluminium oxide. Calculate the percentage yield. So the percentage yield is the mass of the product actually made over the theoretical mass of the product. So here what we have is we have the mass actually made is 28.4 kilograms over the theoretical 31.8, multiply it by 100, and that gives you a value. We needed 3 significant figures of 89.3%. And we're going to leave out this last question. And we're going to finish there as I'm conscious of the time. So please read through them, analyse where you went wrong.